In this video, we will learn about the factory method design pattern and how to implement it using C++ code. Like the other patterns we've learned about in this section, factory method is a creational design pattern. The factory method pattern is useful when we want to create objects, but allow subclasses to alter the type of objects that will be created. As a conceptual example, pretend we wanted to create a shape. Our factory would be responsible for creating shapes, and would have to be able to create different shapes like circles, squares, and triangles. Even though each of them is a shape, each of these types of shapes looks different when drawn to the screen. Now that we understand the purpose of the factory method pattern on a conceptual level, let's learn how to implement it using C++ code. Next, we will create the shape class. Inside of here, we will use the public access modifier and have a virtual void function named drawShape. Next, we will create a class named circle that extends the shape class. Inside of this class, we will have the public access modifier applied to the constructor, inside of which we make a call to the drawShape function. We will also override the base class's drawShape function. Inside of drawShape, we will output circle to the console, since we are currently inside of the circle class. If the code in the constructor gets called, we know that a circle has been created by our factory. After that, we will have a class named square that extends the shape class. Inside of this class, we will have the constructor for a square object, inside of which we will call the drawShape function. We will also override the base class's drawShape function, and inside of here we will output the string square to the console. Then we will create a class named triangle that extends the shape class. Inside of its constructor we will call the drawShape function. Then we will override the base class's drawShape function and print the string triangle to the console. Time to create our factory class. Inside of this class, we will have a public variable of type shape named shape. Then we will have a public function with a void return type named createShape. It will take in one parameter, a string named shape2draw. Inside of this function, we will check if shape2draw is circle. If so, we will set shape equal to a new instance of the circle object. Else, if shape2draw is square, we will set shape equal to a new instance of the square object. Else, if shape2draw is triangle, we will set shape equal to a new instance of the triangle object. Time to test our code. Inside of C++'s main function, we will create a variable of type factory, named factory. Then we will call the factory's createShape function and pass in the string square. When we run the code, notice that the string square was printed to the console, meaning our code worked. In this video, we will learn about the prototype design pattern and how to implement it using C++ code. Prototype is a creational design pattern that allows us to copy existing objects in our program. One example that comes to mind for me when I think of the prototype design pattern is from Pokemon. Ditto is a Pokemon that can copy other Pokemon. It can take on its enemy's appearance, attacks, and stats. A clone method typically facilitates the prototype design pattern. Now that we understand what the prototype pattern is conceptually, let's learn how to implement it using C++ code. We will create a class named Pokemon. Inside of this class, we will use the public access modifier. A Pokemon will have an int attribute named HP, which is short for hit points. It will also have an int attribute named attack. Then we will define the Pokemon constructor. After that, we will create a virtual function that returns a Pokemon named clone. Inside of this function, we will create a variable of type Pokemon named clone that we set equal to a Pokemon object. Then we will set the clone's HP to HP and the clone's attack to attack. After that, we will return the clone. Next, we will create a class named Pikachu that extends the Pokemon class. Time to test our code. Let's go inside of C++'s main function. We will create a variable of type Pikachu named Pikachu. Let's set Pikachu's HP to 20 and its attack to 10. Then we will create a variable of type Pokemon named Ditto that we set equal to a call to Pikachu's clone function. To see the attributes of our Ditto clone of Pikachu, we will output Ditto's HP and attack to the console. When we run the code, notice that our Ditto has successfully cloned Pikachu's stats, and now has an HP of 20 and an attack of 10, meaning our prototype design pattern worked. Advantages of the prototype pattern are that we can easily clone objects without duplicating the code. We can create pre-built prototypes, and we can more easily produce complex objects. The disadvantage is that if we clone a complex object, we need to be careful if it has circular references, because that can leave our code in a circular dependency state, which can be hard to decouple.